What's up guys, welcome back to a brand new academic learning video, and in this video we are going to be covering one of the most important topics of all of geometry. And this topic is called the Pythagorean Theorem before. Now you've probably heard of this theorem before, or at least in one of its names. Now you may have heard it as the Pythagorean Theorem, or a squared plus b squared equals c squared. But what does that even mean? Like, what is a, b, and c? Well, in this video, we are going to be talking about the Pythagorean theorems and, more importantly, in my opinion, Pythagorean triples. All right, let's get started. Okay, so first of all, in previous videos, we've explored right triangles, right? Sorry, that was a very bad pun. But basically, a right triangle is just a triangle with one of the angles being 90 degrees. Now, there's this thing about right triangles, and they have this certain property. Let's say we have these side lengths, and let's just call it some variables, a, b, and c. And now, one property of right triangles is that any right triangle, if you take this side length squared, actually, let's cover a bit of terminology first. Okay, so the side longest in a right triangle is called the hypotenuse. So in this case, it's C. So that is called the hypotenuse. And then the other two sides are called legs, the non-longest side. So leg 1, and then that is also a leg. And now the thing about triangles, any triangles in a general scenario, is that the side opposite to a triangle, so let's say this side right here, we're talking about this, you can determine the length based on how big this opposite angle right here is. And you can kind of think of this intuitively. If that angle is very big, you have a very big angle right there, that side length is going to be very big as well. But if you think of like the angle being very small, that side length is going to be very small. So the side of a triangle, any triangle, is going to be corresponding to how big that opposite angle is. So if we think of a right triangle, then how can we know which side is the largest, or which side is the hypotenuse? Well, we just have to determine which side is opposite of the largest angle, because larger angles means larger sides. So how can we tell which has the largest angle? Well, we know that the angles of a triangle must sum to 180 degrees. But in a right triangle, we already know one of them is 90. So we know that these two angles must sum to 90. So if we have x plus y, that must be equal to 90, because we already have a 90 here. And that must be 180. Hopefully that makes any sense, but if that doesn't, please leave a comment down below. So if these two must add to 90, then doesn't that make sense that they're both less than 90 degrees? So x is less than 90 degrees, and y is less than 90 degrees. Because if we add them together, they're 90, so that means in separate that they're less than 90 degrees. So if they're less than 90 degrees, then this right here is the biggest angle, so therefore the hypotenuse is always the side opposite the right angle. So that's how you can find the largest angle of a triangle. Okay, so now that we've gone over some terminology, let's actually get to the theorem, like you've been waiting for. Okay, so in a right triangle, where we have three side lengths, A, B, and C, what the Pythagorean theorem states is that the hypotenuse, which is the side opposite the right angle, so the largest side, and if we square that largest side, so we get c squared, that's going to be equal to a squared plus b squared. Now, a whole bunch of questions may be popping up in your head, but let's go through them one by one. Okay, so first of all, why is this true? Like, how is there any sort of relation to this? Well, the truth is, this relationship is a theorem. So, like with some other things in my channel, like, I don't know, maybe factoring, there isn't really a cool, like, insight. It's how you can show that this is true is just a lot of algebra, a lot of geometry, and a lot of math. And there are actually like hundreds of different ways you can prove that this is true. And I'll link to one good one below. That's an interactive example. So in this video, I'm not really gonna be doing the proof because it's kind of long and boring, and you won't really gain any intuitive insight to it. Okay, so that's the first question out of the way. But the second question is, well, does this hold true for all right triangles? Well, yes. The answer is yes. If we have any right triangle with AB and C, then C squared equals A squared plus B squared. But which one? Okay, now C we know must be the hypotenuse, but which one is A and which one is B? Like, is the longer leg A and the shorter leg B? Well, the truth is, it doesn't really matter because we're adding them either way. So if we have this one be equal to B and this one be equal to A, that's still going to end up with the same thing. Hopefully that made sense. If not, leave a comment down below. But basically what I'm trying to say here is that how do we know which variables are which in a right triangle? So we know that the hypotenuse must be C, right? But what is A and what is B? Well, A could be either of these two sides, and B could also be either of these two sides. It doesn't really matter which side you pick, because we can just switch the order around, and that would be the exact same thing. Okay, now hopefully you maybe should understand how and why this theorem should work. But let's move on to some examples here. Okay, so let's say we have this length being here, which is 3, and this being 4. Now, how can we solve for this larger length? Well, we can just plug that in. So the larger length C squared is equal to 3 squared plus 4 squared, or that C squared is equal to 9 plus 16, or that C squared equals to 25. So if C squared equals 25, then C equals 5. So that's basically it. Basically, if we have two lengths, then we can substitute those lengths in and solve for the third one. So in this case, we just substituted the two legs. But we could also, if we had something like, if we knew that this one was 5 and this one was 3, then we could also say that, well, 5 squared equals 3 squared plus, let's call this side x, plus what number squared? And now here we could solve for x as well. So this is going to be 25 equals 9 plus x squared, or that 16 equals x squared, or that x equals 4. Okay, so that is how you can use the Pythagorean theorem. But there's one more concept we can learn, and that is Pythagorean triples. Now, notice how this triangle has 3, 4, and 5. And that is kind of nice. It's a nice integer solution because not all, let's say we have 2 and like 3, then this will be the square root of 2 squared plus 3 squared. I'm not going to do all the algebra. This is just a shortcut, so that's going to be square root 13. So not all side lengths are nice, but this is nice. It's all integer side lengths. And when it's all integer side lengths, what we call that is a Pythagorean triple. A Pythagorean triple. And Pythagorean triples are just 3 numbers that satisfy the Pythagorean theorem, so you can construct a right triangle out of it. So this specific Pythagorean triple is called a 3, 4, 5. Well, because there's a 3, a 4, and a 5. But there's also many other Pythagorean triples. Like, I don't know, maybe like, I think one is 5, and then 17 and 12. Correct me if I'm wrong there, but I think that's one of them. Yeah, so basically Pythagorean triples are just sets of numbers, 3 numbers, that satisfy the Pythagorean equation. So 5 squared, so 5, 17, or no, 5, 17, and 12. And you know that this satisfies it because you can plug it in. 5 squared plus 12 squared does indeed equal 17 squared, so this is a real right triangle. Okay, so hopefully that made a little sense, but if not, I know I said this like a billion times, but please leave a comment down below. But one thing you could do with Pythagorean triples is actually apply similarity to it. Now hold on, because you might have a lot of questions. Okay, so let's say we have 3, 4, 5. We know that this is one of the triples. This is like the most common triple. Make sure you memorize that triple because it comes up a whole lot in geometry. So if we have a 3, 4, 5 Pythagorean triple, and let's say we just have a different triangle. Let's say we have 8, 6, and x. So how can we solve for this side length? Well, one thing we could do is, one thing we could do is use the Pythagorean theorem, but we don't have to. Do you notice how these two triangles are similar? They're just a scaled up version. You're multiplying this by 2, you're multiplying this by 2, so therefore you could also multiply this by 2, so then we know that x equals 10. So that's another concept we can learn here. We have Pythagorean triples, right? But we can create even more Pythagorean triples if we just scale that up. Let's say we have our 3, 4, 5 triangle here, and then we select it, and now we scale it up. And let's say we scale this up by a factor of 3, and then this 3 becomes a 9, this 4 becomes a 12, because we're scaling all the side lengths by 3. So now we just have another Pythagorean triple just by scaling up a previous one. Now, do you see how that kind of relates to similar triangles? Because if we have 3, 4, and 5, and we have 9, 12, and we want this one, well, we just notice this is just a scaled up version of a 3, 4, 5. And then we notice the scale factor, so then we can just solve for the corresponding side lengths. It should make a little intuitive sense how these are similar because we're just scaling up the triangle, right? So they should be similar triangles. Okay, so let's do a couple more practice problems. Let's say we have, let's say we have this is 15, and this is 20. No, sorry, let's say this is 15, and then this is 25. Now what's this? Well, just notice that this is just a scaled up version of a 3, 4, 5 triangle. We're scaling the 3 by a factor of 5. We're scaling the 5 by a factor of 5. So we're also going to be scaling the 4 by a factor of 5, so this should be 20. And now you might notice something here. Well, wait a minute, this orientation is not the same. Because here, let me just give you a better example here. If we have x, 15, and 25, and we're comparing it to 3, 4, 5, this orientation isn't right. Because this is going to be 3 times 5, this is 5 times 5, so this will be 4 times 5. So this is a scaled up factor by 5, but notice here, this 3 side length should be right here, but in actuality, it's right here. But the truth is, that doesn't really matter, because when we're talking about 3, 4, 5 triangles, the legs don't really matter where they go. If this was 4, and this was 3, this would still be similar. It doesn't, because 4 squared plus 3 squared is still equal to 5 squared. And you know how I was talking about before, the length, where the legs are don't matter? This is the same concept. Okay, so this is just a pretty brief introduction to the Pythagorean theorem. Or sorry, I shouldn't say pretty brief, this was pretty in-depth. But if you have any questions, please let me know. I'm always trying to make my videos better. And if you're confused, also let me know. And yeah, I'll see you in the next video.